Welcome to another episode of the AI Lyceum. Today we have Pascal here, who is a Silicon Valley tech leader and product leader turned into sustainability advocate. He's got amazing expertise in cloud, DevOps, and in understanding the climate and the impact of technology on it. So I'll pass over to him to explain his role in more detail.
Yeah, thanks for having me, and glad to be here. So I'm currently based in Silicon Valley. I spent 25 years in the tech industry, working for large companies like Hewlett Packard and startup companies, working on data center automation. And then 3 years ago, I decided to launch my own consulting practice and focused on how to make digital consumption more sustainable. And as a result, I launched a few courses on sustainable cloud engineering and sustainable AI. And as well, I offer services and I help companies trying to figure out ways to optimize their usage of AI to make it more sustainable and lessen its environmental impact. So that's my background.
That's really interesting that you do both training and you consult for clients because I feel like the sustainability area of technology in general and of the world and advertising and AI are all being a bigger focus now.
Yeah, exactly. And this is a big part of the work that I'm doing is creating awareness essentially and bringing this knowledge both to the general public, but as well internally. And I even work with government organizations.
Nice. And if we're to define sustainable AI, what does it mean to you and why does it matter now more than ever?
Good question. So, in simple terms, sustainable AI means how do you use AI without destroying the planet? And so, in other terms, is how to use this tool, this technology responsibly and within the planet's boundaries. And when I talk about planet boundaries here, we're talking not just about carbon emissions, but also all the natural resources that are needed and the raw material needed for building all this hardware, as well as water consumption, which is also a big part of the impact of AI.
Um, for those who don't really understand, how does CO2 come from running AI and running these tools? And why does water matter and where is water used? Because a lot of people listening to this, they don't actually know how these things come about. So I'm just thinking about my laptop here. I see you on my
Oh,
screen.
yeah.
I can't see any water anywhere. I can't see any CO2. So how would you explain that to people?
Yeah, very. Also, it's something that I always start with in my courses is that it seems so clean when you use these digital technologies, right? You have this laptop, and why bother? The laptop consumes very little electricity, and everything seems to be harmless, essentially. But at the end of the day, when you send a request to, for instance, your LLM in a typical conversation that many people do nowadays, it goes in the back to a data center and a server actually hosted in a data center. And this server itself, and you have thousands of servers, is powered by electricity. And some of those data centers are consuming as much electricity as entire cities. And and then this electricity is coming from a power plant, and this power plant might be powered by fossil fuel um, and gas or coal, and this as a result generates carbon emissions. And so that's how you can relate, the simple, harmless task or use case of using an LLM to eventually additional carbon emissions. And when everybody's trying to decrease carbon emissions, we're seeing a trend that data centers are actually increasing carbon emissions. And the reason is that there's not enough renewable energy right now to supply all the needs of new data centers that are being built. And also new data centers, they require 24/7 electricity, which means that you have to use, if you're using renewable like solar and wind, you have to complement it with maybe battery technologies or some backup system, as well as potentially you can use hydropower. And now we're talking about building those nuclear power plants that are going to be essentially filling the gap. But building nuclear power plants is 10, 15-year projects. And in the meantime, the race is on to quote unquote win the AI general AI or whatever that is AGI price from all those big tech companies, and they're building bigger and bigger data centers. And we're talking now about the Stargate project, talking about 10 gigawatt data centers, which is just to give you that in perspective, it's the equivalent of powering 8 million homes in the US. So, we're talking about really huge, beyond one city just to power those. And in the same time, at the federal level, they're supporting that growth by saying, okay, so any power source is good, and let's facilitate the reopening of, or the prolongation of coal power plants, and had more coal mining as a result, because we need to essentially fill that energy as soon as possible, and we can't wait for nuclear power. And so this is going to result in huge potentially increase in emissions, but also in additional pollution, because coal, as you know, is a huge source of air pollution as well as water pollution. So this is why, in terms of timing, this is really important to talk about this topic right now.
Yeah, it's a super interesting topic, and obviously when they mine for these precious metals and raw materials to use in GPUs, it also releases CO2 into the atmosphere, right? So it makes us more conscious of what we're doing.
Yeah, exactly. So the fact that you have also to build this material in the first place, and they require a lot of the mineral extraction that you have essentially, in order to extract 1 gram of one of those rare metals, you have to extract a ton of raw material, and then use water to essentially filter it and just get to the actual one that you need to build your electronics. And so huge energy consumption to extract the materials from the raw material, as well as huge water consumption as well, and water pollution resulting from it. So big issue as well from just building all those electronics, all those GPUs. And we don't have today a way to have sort of a closed loop complete recycling of electronics. It's right now very, very, very few companies are looking into that. We've seen some companies like Fairphone or smartphones trying to use more of a sustainable recycling parts, but with AI, we're talking about all those servers and processors, and very little of it is recycled today. So, yeah.
Yeah, the recycling part's very interesting, but another part that's very interesting is concepts like green IT and GreenOps. Are you able to explain how these concepts can help businesses and help the world become more sustainable?
Yeah, sure. So green IT is beyond AI, right? It's all about applying sustainable practices, like finding ways to optimize your IT consumption in terms of efficiency, also deploying infrastructure in lower carbon regions. So not all regions in terms of electricity are equal. And there's a really good tool called Electricity Maps that many are using in the community to figure out at very dynamically what's the carbon intensity of a given electricity grid in different regions of the world, different countries, different states, if we're talking about the US. It's very granular. And so green IT engineers will be concerned about deploying their workload in the lowest carbon intensity region to decrease the carbon emission. And then, so this is one of the best practices. And the other one is all about automation and implementing DevOps practices to minimize idle machines and minimize waste. So really trying to maximize your efficiency and allocation of hardware. And then the GreenOps team has a little bit of a different role. The GreenOps team is primarily concerned about reporting emissions, so measuring emissions, carbon emissions, as well as reporting them for scope 1, 2, and 3. Typically, cloud emissions for most companies are scope 3, but they still want to report them. And once you're able to measure them, trying to mitigate the increase of usage. So in many companies, some of my clients I work with, you're seeing increasing emissions, cloud emissions due to the AI usage, AI training, if they're building their own models, or AI usage in general. And so they're concerned about mitigating those emissions by choosing maybe more efficient model that are less energy intensive. GreenOps team will work very closely with the FinOps team, which is the team that's concerned about minimizing the cloud costs. And it's because very often these work hand in hand. So cloud costs are going to be correlating to emissions, more usage, essentially, which correlates to more emissions. So if you decrease the costs, you decrease the usage and you decrease the emissions. So this is another part about organizational functions that work together.
And moving beyond organizations, what can consumers do? So what can people who are listening to this episode do to reduce their impacts on the environment?
Yeah, so that's a very good question, because many people feel powerless, right? You kind of have all those news about billions of dollars that are spent in data centers and cloud providers investing more and more into those large models. But what can you do as an individual? And then we hear also on the other side the news that one simple prompt to an LLM really doesn't consume that much. It's just like a drop of water and sort of a very low number. So we hear that sound bites here and there, and you don't feel that essentially not only you can do anything about it, but also that it's such a big deal. But then the problem is that if hundreds of millions of people are starting to use these tools on a day-to-day basis, essentially replacing your internet search, then it becomes huge in terms of energy consumption. So there are ways first to measure and at least estimate, not measure, but estimate the carbon emissions and the energy consumption using plugins. And I developed one of those called AI Wattch, which is a way for you to visualize your emissions as you're interacting with an LLM, such as ChatGPT or Claude from Anthropic, and then looking at how much these total energy and emissions is accumulating over time as you're having more and more conversation over the course of a day. So this is a tool that's meant to create awareness, and the way you can change your behavior and improve that is by implementing better prompting practices. And I'm talking here about the specific domain of chatbots, right? AI is very large, but we've been focusing on Gen AI and chatbots in particular because they are such they have such a high energy consumption, and they are prompting best practices that people can implement to minimize their energy consumptions, be more concise, avoiding to use certain keywords, maybe politeness, etc. And so that's how we try to integrate that as well in AI Wattch. But this is one of the things that everybody, anyone can do as they're just trying to minimize their footprint individually.
Awesome. I think that's the first time ever that people say that it's okay not to say please and thank you. So I'm pretty sure people will be very happy not having to be well mannered when talking. So we've talked about the sustainability in terms of green IT and GreenOps. We've talked about your amazing extension. What sort of data are you using to quantify and estimate these emissions within these chatbots? Because there are lots of different sources around, and no one seems to be too sure at the moment what's the holy grail of measurement.
Yeah, so here, there are two things, right? There's measurements and estimation. So measurements is something that's in a very controlled environment. You sort of have control, you have ownership of the model, you can test it on a specific machine, and then you're going to use tools like CodeCarbon to measure the energy consumption of the hardware behind the scene. So you have sort of an end-to-end control, and this is something that works very well with open source models. So the Hugging Face community has put together the AI energy score, which is a methodology to measure the inference of different models and compare between each one of them, right? So you want to sort of have a benchmark and then choose the one that's most energy efficient based on this energy score. And this is something that Hugging Face has been publishing and been very trying to standardize this as a method that everybody can use. But then, obviously, sometimes you have closed models that are not disclosing all their, it's not possible to essentially run those tests. And in this case, you have to estimate and figuring out, based on the knowledge of the overall architecture of the model, using transformers, how you're going to look at the compute time, which is one criteria, how long it takes to get a response back, as well as the number of tokens. So the number of pieces of information essentially that's being returned and processed. And so based on those 2 bits of information, then you can run calculation and estimate the energy consumption, and then translate it based on your energy intensity. You can translate it into carbon emissions. Yeah.
That's really interesting. Thank you for giving me information on that. On the flip side, I've just seen a report recently that says 40% of climate tech funding went into AI-related startups in the UK. So using AI to help with climate action. So instead of it being making AI more sustainable, it's being more sustainable by using AI, which I find quite interesting.
Yeah, definitely. That's a big debate in the community and beyond, actually. Sometimes it's been used as justifying the fact that we're going to continue investing in AI growth because AI eventually benefits will outweigh the impacts and the problems. But on the other hand, it's very difficult to measure precisely the benefits of using AI for solving problems like climate. Because many of those are theories, right? And then a few have been applied. And also the other part of it is that many of the benefits of using AI to solve specific problems like weather forecasting, fire forecasting, biodiversity, etc., are not using actually models that are very energy intensive because they don't. Primarily, they rely on very specific narrow data sets, and the architecture that they're using is not Gen AI. They're using more type of forecasting model, deep learning forecasting model that have been around for many, many years. And the paradigm of energy consumption is very, very different. So all those use cases are evolving as many are trying to adjust them to provide analysis of large data sets, or at least analysis of results using GenAI. So that could be also become potentially more energy intensive to solve some of those use cases. But in many cases, for instance, the number of inferences is not that great because it's only scientists that are going to analyze the data, not everybody. And so as a result, the problem is not about necessarily energy intensity. The problem is more about having a use case that can benefit the planet or benefit humanity. AI is just a tool, right? And you could use it with a very positive intent, or you could use it with something that's more entertaining, for instance. Like you've seen recently, the announcement of Sora that has been released a bit more broadly by OpenAI to generate quick videos like TikTok through AI. Very energy intensive. You can question the usefulness of that and the benefit for humanity, but for sure that's going to have a big impact on energy intensity and eventually carbon emission. Another example would be, carbon AI used for improving oil drilling. So finding sites essentially that are more suitable for finding more oil or coal mining. And this is going to be very helpful for those types of industries, but maybe not helpful for the planet and for carbon emissions. And so it's all about the intent and the purpose. And unfortunately, we need to, as a community, putting more emphasis on companies to balance what are they trying to do with the energy and the impact on the planet. So
very, very valid points there, and I'm sure everyone listening is going to be taking a lot of notes from you. Let's move on to another area now. So in terms of infrastructure, we're in the point of AI where we're laying the infrastructural grounding for the future of using these tools. So how do we balance sustainability with scaling the power needed for these data centers to create amazing AI? And then on the other hand, can you define what inference is and how it works its way into this process?
Yeah, so maybe I'll start with the definition of inference versus training, because I think it's good to get grounded on that. So training, essentially, when you have a model, you're trying to first run it against data sets and have it produce results that are going to be predict, essentially, results based on new data. So this is the training part, and it can take a lot of energy because we're talking about very large data sets and a lot of computation time, but it's more of a one-time event. And then inference is essentially all about the usage of the model. And once the model has been released to production, it's able to predict new results on new data. And at this point, it all depends on how many people are going to use the model itself. And if we're talking about scaling, we're seeing that after a certain threshold, like maybe 100 million user, which is nowadays pretty typical about all those chatbots, general use chatbots and LLMs like ChatGPT, you are seeing an inversion of the energy required for training versus the overall energy required for inference. And we're seeing that the energy spent for inference, which is the usage, is going to be more like 60%, and 40% will be for the training. Even though those are very large models that requires cluster of thousands of GPUs, there's still going to be more energy required for inference, because the fact that so many people are using it. So it's the law of large number.
Yeah, and in terms of training, you mean training a model to learn, to identify patterns, right?
Yeah, exactly. Yeah, so it's the first phase, and it's really common for any machine learning. This is really how machine learning works. or any model will have to go through this training phase. And that's why one of the best practices is that you would want to pick a model that's already pre-trained, so that the next step after that is to fine-tune it to your specific use case. So you save the energy of training the model in the first place. So you never want to really start from scratch, unless you're one of the main leading labs with lots of resources. What you want to do is pick a model that's already been trained and then fine-tune it and optimize it. And there are many techniques to decrease the energy consumptions of a given model by decreasing its size. And techniques such as quantization and pruning are very commonplace now to minimize the performance degradation, but decrease the size and the energy computation needs of the model.
So he talks a lot about theory. I'm going to give you an example, and I want you to explain to people everything about making it sustainable. So here's my example. I want to build a company that makes the best rockets to go to the moon and beyond to other planets. I want to build an AI thing, Gen AI predictive model, to help my rocket be guided towards planets and the moon, etc., in the most efficient way possible, and to help use the fuel in the best way possible, and to help all of the people taking the rocket there to organize their schedules. So how would I make that a sustainable process? What sort of things do we
Yeah,
need to think about?
yeah. So that's a good one. So the first question that you would want to ask yourself is, do you need AI in the first place? Not, all we tend, AI is so popular right now. There's a big hype about this that everybody tend to throw AI for any type of problem, technical problem to solve. And so in this case, AI can be used to do prediction and maybe to do some optimization, but maybe not in all of your example would it be used. It would maybe some more simpler technologies would be probably more adequate, based on physical models, etc. And then when you decide to use one particular AI model, maybe or AI technology, then you're going to look at the specific data, for instance, that you're going to use, the data sets, which is usually the first step to be able to train a given model. And for that, you can use, in some cases, open source data sets, and there are different communities that provide those, like Kaggle and Hugging Face. And then you would look at selecting or comparing different models for your use case that are essentially giving you different with good performance profile, but different energy profiles. So you're going to measure and quantify the energy consumption, so relative energy consumption of those models. And from a sustainability standpoint, do that from the very beginning. So essentially you want to infuse sustainability and decisions on impact from as early as possible, right? Because once you made a decision on the model, then it's already too late. So what you want to do is base your specific model selection on performance as well as energy consumption. And then you're going to train your model. And as you train your model or fine tune your model, if you're using a model that's pre-trained, you're going to make sure that you're selecting a region that has low carbon intensity. So most of the time, people will do that in the cloud, not on their own infrastructure. And here you have the choice of different cloud providers in the first place that have more or less better breakdown for you of your own carbon emission consumption. And if you compare, for instance, the main one, AWS, Microsoft, Google, you've seen Microsoft and Google have been ahead of the game in terms of providing better reporting for their customers. And then selecting within these customers the lowest, the carbon intensity that is the lowest, when you're going to train your and fine-tune your model. And I said fine-tune because here you're again applying some techniques that are going to be optimizing your model for decreasing its energy consumption while keeping track of the performance of the model so that you still get good results. And if you're looking at your rocket, obviously you want to have really good prediction, maybe on the optimal trajectory to minimize fuel consumption, assuming that this is one of the problems that you're concerned about. So this is going to be your performance criteria. And then you're going to look at the overall model energy when you actually have to run it. So that's another piece of the puzzle that you're going to look at. And here it's again deploying your model in lower carbon, or running your model essentially in lower carbon intensity region, and looking at additional complementary data that you can add to increase the performance of the model. So this is sort of a rough end-to-end picture of how you would go about that.
And when you say running a model in a more sustainable physical area, do you mean that the server I'm using, the server location I choose, is going to be, let's say, X versus Y, and X is way more sustainable, rather than my computer being in that environment right now? So I could be anywhere in the world referencing a server in a green location. Is that what you're saying?
Yeah, so the server itself typically is going to be hosted in the cloud. And then you're going to look at cloud regions where the grid carbon intensity is the lowest. And based on also your latency and performance. So when you're running it, there's this criteria of latency. So you have the lowest latency as well. And the other thing that's important to remember is that you can cache the data. So if you have repeated requests, you can cache that data and save on transfer and eventually energy consumption.
Okay, that's interesting to know. And what are some of the, if I was a leader, I'm a leader of this rocket company, persuade me as to why I should be sustainable, and how do I know when I am sustainable? At what point in time do I say, hey, I am being sustainable? Because there's a difference between being better, and there's a difference between being better and sustainable.
Yeah, so as a leader of a company, your primary objective very often will be making sure that your shareholders are happy. And that means caring mostly about the bottom line and cost savings or revenues, right? And then if you're altruistic, maybe you're going to care about the planet. But in reality, if I want to convince you that sustainability is a good practice, I will tell you that sustainability is actually a good business practice. And it means that you're trying to optimize processes and run your business as most efficiently as possible, so minimize your cloud costs. And if in particular you're interested to use AI, you know that those cloud costs are going to be large and increasing. So you want to be really mindful about your usage of those cloud costs. So this is going to help you save money, essentially. So that's the first selling point. The second one is that it could give you competitive advantage, because if your competitors are not doing it and they don't care, maybe your customers will care and they will select you instead of others. And the third point is about regulations. So maybe not in the US at the federal level, but in California, for instance, at the state level, they have mandatory now reporting of scope 1, 2, and 3 that are coming up with the new rulings. And in Europe, it's been in place as well. So you do have to be mindful about being compliant on carbon emission reporting. So that's another part that I think is of concern for a business leader.
Well, you managed to convince me quite well, but there's one more element, is that I'm under a lot of scrutiny in the press, etc., about what I'm doing, and we're at risk of greenwashing. So, can you define what greenwashing is, and can you let me know how I can navigate being accused of greenwashing whilst doing these things? Because I want to shout about all of these changes I'm making.
Yeah, so that's in the last, I would say, 2-3 years ago, everybody wanted to claim that they had net zero goals achievable by 20, a date somewhere in the future, without actually having clear plans or commitments about them, or any really understanding of what it would take to achieve those goals. And now, since the beginning of the year, things have changed dramatically, almost 180 degrees. And nobody is talking about those goals anymore for two reasons. First, they're not very popular with the current administration, and especially with tech companies. They're trying to. I'm talking about more at the U.S. level, but tech companies are trying to be in good terms with the government, and so they've been moving from greenwashing to greenhushing, which is essentially not talking about these at all publicly, but in the back end and in the background, continuing to work on it internally. And as a result, we've seen also the fact that given that we have this increase and commitment of increase to AI growth and data center growth, those net zero goals anyway have had to be revisited, and none of those are achievable anymore, because you can't have both huge growth into your cloud infrastructure and able to reduce your emission at the same time. Right now, there's no way you can achieve that. And so, given those two components, we're seeing now that the efforts are more trying to mitigate the impact of AI and digital consumption. But I've seen that with some of my clients, like Autodesk, for instance, that are really diligently working on trying to figure out ways to diminish and decrease the impact of their emissions. And so that's one trend that I'm observing, is that it's more now trying to be continuing to do that effort regardless of the politics, and working for the long term, essentially, because this is not going to be the problem is not going away in the next 2 years, right? The problem of climate change, it's a long-term problem that's maybe accelerating, but it's not going away because there is an election or a political change. And so companies who are already well established, they understand that this is a concern that they have to worry about. And it's important that they work on it continuously, independently of the flux of the political will.
That's a really thorough answer, by the way. And in terms of the way to become more sustainable, I was talking to Robert Coase from GreenPT, the founder of GreenPT, and there are, in some instances, the data centers are right next to massive land filled with water, so they can use that water and recycle the water from the data centers back into the lake or whatever else is around them.
Yeah, there's a number of efforts, and I must say that outside of the US, for instance, in the UK, there are many efforts to, even from the government, to be very transparent about AI and its impact, environmental impact, and as well as trying to figure out how to use these data center more efficiently. So there is increasing the efficiency of the power usage, but as well as there's a lot of heat that's emitted from those data centers. And for instance, in data centers that are located close to urban areas, which is the case often in Europe, and we're talking here about, they're trying to use the heat to heat up homes or public swimming pools or even greenhouses, agricultural greenhouses.
If there's any innovation that you're most excited about right now in the world around sustainability and AI, what would it be?
So to me, the most interesting, one of the most interesting trend that I'm observing is the fact that there's a recognition that bigger is not always better. And there's really a lot of innovation that's happening in using smaller models that have really good performance. And a lot of breakthroughs have been done in that space. And we're talking now about even embedded models, which are models that can run on hardware like smartphones, and that don't need to run in the cloud essentially, and that have a much smaller energy consumption. So it remains to be seen if this trend is going to have a net positive impact, because if people have to upgrade all their devices to run those models and purchase new smartphones or tablets as a result, then it's going to increase the overall footprint of this innovation. But generally speaking, I think this is a positive trend. And also the fact that I'm seeing kind of a bottom-up, and it's not really innovation, but here it's a bottom-up awareness of this problem from the general population being more concerned and trying to do something about it. And this is about talking to my students and talking to different engineers from my clients. A lot of them are actually concerned about those and are trying to do something about it. And also, the other point I would mention is that the main breakthrough that everybody's been talking about is the breakthrough with Gen AI and the LLM transformer-based architecture. But we've seen that it's reaching some limits now, and I'm hoping that the next architecture of models, whatever that is, could be more energy efficient, because people understand that running these super high compute models are very costly. And in order to scale any efforts, you need to actually contain the costs. And so that's one of the incentive also for the future iteration of those types of tools to be more efficient, is because they become really, really too costly. And actually right now we're really in I think a bubble in terms of inflation and evaluations of all those AI startups. And at some point, we're going to see probably a slope, a downward slope because of that. And that could actually be positive for the impact as well, for the environment as well. So
you mentioned so many good points there. One of the points that I thought was back in 1990s, early 2000s, until the iPhone came out, we were buying new phones every 1 to 2 years, or at least I was. So we were chucking away a lot of mobile phones or devices. Nowadays, I'm not sure what other people do, but I keep a device for a little bit longer than that now. And I just download the software onto it. So operating systems, right? We just keep updating it. So that's an interesting point. You're talking about two things, which I see as the key points of what you just said. The first is device level modeling, and the other one is small language models. So can you define the difference between the two? And in terms of how do I quantify it? How do I quantify small language models, and how do they work?
Yeah, so small language model is essentially a very specific area of AI, which is trying to generate language, right? Text, and maybe trying to generate sometimes images from language. But there's always this idea that you're going to interact with this model like a chatbot through text and different language, primarily English. And the idea is that by containing these model size, because they do require a lot of parameters initially to work, containing this model size, you can still obtain very good results. In particular, when you're trying to solve a given problem that's fairly narrowly defined. So the idea is that the more general you are in terms of your ability to understand language and do many, many different things, the more energy intensive you're going to be in terms of the larger your model is going to be. But then on the other hand, you can be a lot more efficient if you have a narrow tasks and you're essentially trying to just use a subset of that large language model and solve the task, the specific task in particular. So instead of trying to resolve, for instance, any language problem, you're just trying to generate code, for instance, for developers, or you're trying to solve translation into different languages, or you're trying to summarize, right? So essentially subsets of those languages, and you can create as such small language models that are going to be much more efficient at doing this given task. And these are going to have a smaller number of parameters, and as a result, less computation requirements. And then embedded AI is a little bit different because it's all about running the model, not training anymore. So small language model is just, the model itself. So it's got training and inference. Embedded AI is more about running the model. So this is all about inference. Instead of running it in the cloud, you're running it on your device itself. And as a result, you're having a very, very small memory footprint, as well as very small computation compared to what you would have in the cloud. And so when you're constrained in terms of hardware, you become more clever about how you use this hardware. So it's all about essentially designing something under constraint. And that's why when we had the sort of the DeepSeek moment at the beginning of the year, it was all about how those people who didn't have access to those high-end chips from NVIDIA were able to still to generate a model that has really good performance with a lot less resources.
That's a very thorough answer, as always. I wrote down something which I thought was a really, really key point. So you said the difference between a large language model and a small language model is a large language model can do everything. It's a generalist, right? And a small language model is basically a specialist. So the way I compared it or wrote it down here was, I said a large language model is like a Swiss Army knife, and a small language model is like a knife. It is a specific task. If I have a knife for cooking, and a Swiss Army knife can do lots of different tasks. So that's how I see the differences. Is that a correct assumption?
Yeah, I think that's fair to say, and it's also the fact that you're really applied many techniques to optimize that large language models, so that it becomes something that's a lot more efficient. And these techniques can be applied regardless of the task, but very often, if you know in advance what task you want your model to have the best performance on, that's going to be your benchmark. And that's how you measure, the performance of your model, right? And once you establish that benchmark, then you can prune or tune up your model so that it becomes really good at that particular task, and you don't care too much about everything else, right? So you don't care about creating fun videos, but you care about this particular use case of generating good code for developers.
Yeah, that really makes sense. It's kind of like having your own your own sort of working group of different employees. You have one small language model for one task, another for another task, etc. Moving on to the last two questions. The penultimate question is, what are you most excited about in AI at the moment? What really makes you excited about the future?
Yeah, so right now I'm cautiously optimistic about AI. So we've seen, in the news the fact that the growth of AI infrastructure and data center buildup is still continuing, and we've seen all those announcements of ever bigger data center that are going to be probably powered by best case scenario gas turbines, worst case scenario um, coal power plants, and so that's the news that makes me think, okay, maybe it's not, I'm not too optimistic about it. But then we're seeing also, I'm seeing a lot of interest, not just in the fact that we have um, a number of interesting use cases that AI can be used to solve the climate in specific areas that are very promising, but also the fact that we have a community that cares and that's growing. And I was just attending a panel yesterday in San Francisco, part of a panel, a discussion panel where we shared, some of those best practices, and we had 100 people registered. We have the full house, and we had 350 people on the wait list, which gives you an idea, of the level of interest in the local tech communities, which tech communities, especially in the Silicon Valley, is traditionally interested about, innovation, growth, and doing this, and eventually problem will sort themselves out, especially when it comes to the environment and the footprint of those technologies. But here you can see really that people are concerned about it, and they're trying to do something about it. So there are a lot of innovators as well and entrepreneurs that are going to pick up, all those challenges that are remaining. So that's what keeps me optimistic. And also the fact that a lot of my clients and companies that are reaching out about this are genuinely concerned about it as well and trying to do something as large tech companies.
The last question from me is, I always do this now. I ask a question to the interviewee for the audience. So the audience has to answer this question in the comments or on the LinkedIn post or wherever else it is. So my question to you is, what question do you want to ask the audience?
My question would be, um, are you concerned about these topics today in your day-to-day job? And are you interested to learn more about what can be done?
I know I am. I'm very interested in the topic, and I love to learn from people like you about what we can do. I'm cautiously optimistic, so I'm optimistic with AI. I think that AI is a massive change for humanity. We can make great changes happen. We could probably make things way more sustainable by using this amazing technology to find out new ways to be sustainable. So it's kind of like, figuring out the way to sacrifice maybe something in the short term for the greater good of humanity, right? Where we can use solar power, kinetic energy, maybe, in other ways that we never thought about in the past. So I just want to say thank you for being on the podcast. It's been great. I think we've had a great conversation. We've covered so many different angles within just 50 minutes. So yeah, it's been great, and hopefully we can get you back on in the future when we've got even more things happening that are warranting your expertise.
Yeah, thanks for inviting me, Samraj. It was great talking to you.